All right, so new unit today. What we're going to start talking about today is exponential functions. So exponential functions is basically when you have a function and the exponent is a variable. Okay, so normally we see variables kind of down below, right? So now we're going to see them as exponents. Okay, so that's going to change how the functions look and how they act. All right, so next page. When Connor was born, his parents put $1,000 into an account to give him on his 21st birthday. However, his parents forgot the yearly interest rate. So on the table on the next page, I have all of the values of the amount in the account as the years go on. Okay? From these values, we're going to determine an equation that represents his interest rate in the account and how his account acts over the years. Are you ready? Okay. Hold on. All right, so here's my year. In year 0, I have $1,000, and that should make sense because how much money did they put into the account? $1,000. It's okay, just use that. All right, so year 1, I've made how much money? I've made $40. Good. How about year 2? I've made $41.60. Year 3? More, right? All right, so am I earning an even amount each year? No, what's happening to the amount each year? It's getting bigger, right? And it's getting bigger faster, okay? So the more years I go, the bigger my amount is getting faster. So what's happening here is I'm starting with this amount, and it's going like this. It's getting bigger and bigger and bigger and bigger and bigger and bigger and bigger, okay? So as time goes on, I'm increasing faster. This is an exponential function, all right? All exponential functions have this same general shape. Okay, they kind of look like that swing up. Now, this is increasing, agreed? Decreasing will look like this, but still has that same shape. Now, we know linear looks like a what? A line. Absolute value? A V. Parabola? Quadratic? A U, right? Exponential? Like this, right? Ooh, shouldn't have gone up. So it kind of goes up, okay? So they all have this general shape, and you need to be able to look at these and know exactly what kind of function it is by looking at it, okay? So generally, what do we do with tables? I have all this information. What do I normally do with it? Plot it into a what? Scatter plot. How do I get a scatter plot in the calculator? Yeah, now I've already got the page in there for you. This is data and statistics, right? Now, right now, my data is just tossed on there. What do I need to do? How do I organize it? Good, I need to click to add my variable. What was my domain? My domain was years. Very good. Remember, domain means X, right? And what was my range? It was values. Good. So I've got this nice little curve going on, right? As the years go on, I'm increasing in value. Okay, so now what do I want? What do you think I want? I want the equation. Where do you think I go to get it? Menu. Analyze. Regression. Good. What kind of regression? I want the exponential. Very good. Okay. So I get 1,000 times 1.04 raised to the x. Okay, what do you notice about this equation? It does have an x as the exponent. What else do you notice? Okay, read the problem again. Connor was born. His parents put $1,000 into an account to give him as a present on his 21st birthday. However, his parents forgot the interest rate. Let's go back. What do you notice? How does this relate to the problem itself? Yeah, exactly. $1,000, right? There's my 1,000. So whatever is in this place right here is your initial amount. You should be writing this down in your notebooks or wherever else, okay? That's your initial amount, whatever's in that place, right? Okay. What was my domain? Years. What's domain, X or Y? Okay, so what does X mean? Generalize it. Generalize it. What is years? What does years represent? What time? Yeah, so here's your time. Okay, here's your time. So I've got my original amount. I've got my time. What does my f of x wind up being? My y value. The amount at the end, right? Or the value. Amount after the interest has been added, or the value. Okay? So I have one more piece that I need to be concerned about. Yeah, what is this? Got to have something to do with the interest rate, right? I'm increasing. I need to know that my money is changing, so how is it changing? So yeah, this is going to be my interest rate, but we do something kind of different with it. It's 1 plus or minus the rate, okay? 1, like 100%, plus or minus the rate. Now, plus is if I'm increasing in value. We call that appreciation. Minus is for if I'm decreasing in value, which we call depreciation. Give me an example of something that depreciates in value. Cars, absolutely. You drive them off the lot, they're worth less than what you paid for it, automatically, okay? So that's something that depreciates. Appreciates, savings accounts, CDs. Do you guys know what CDs are?
Oh, yeah.
No? Okay, a CD is, let's say I have $500. The bank has these things called CDs that have a better interest rate than a savings account. So let's say they're 4%, where a savings account is 0.1%. Okay, so what you do is you take your $500, you put it into the CD, and it sits for 4 years. You can't touch it. At the end of 4 years, you can get your money back out, and you've earned 4% interest over the 4 years. Okay, so that's what a CD is. So that's something that appreciates in value. Okay, so 1 plus or minus the rate. Now, something tricky about this. How are rates generally given to you? As a percent. How do we have to write them here? As a decimal. Must be written as a decimal. I guess decimal has an M. Okay, so it'll be given to you as a percent. You have to change it to decimal. So let's do an example of that. 4%. .04. Move that decimal 2 places to the left. Okay, starts here, 1, 2. 2 places. Got it? Okay. All right, 0.04 from percent to decimal. All right, so tell me, what was his interest rate in the account? No? What? Okay, remember, it's 1 plus or minus the rate. What was my rate? Take out my 1, 4%. Okay, the rate was 4%. Okay, 0.04, what's on the end here? 0.04 as a decimal, change it into a percent, 4%. Okay? So the rate was 4% in his account. What do you guys think? Yeah? Okay, so your general form, your general equation, A equals P times 1 plus or minus R raised to the T. Am I going to give that to you? Nope, got to have it memorized. Okay, that has to be memorized. And we'll talk about what all those variables mean in just a moment. Are we okay? Okay. So what was the interest equation? We got that, right? You guys have that written down? All right, so let's try another problem. You ready? Due to an environmental spill, a farmer is losing the amount of land on which he can plant crops. On page 3.2, shows the amount of usable land for each year. Determine an equation that models the amount of land the farmer can use each year. All right, environmental spill. Is he going to have more land for crops or less land for crops? So is it going to be an appreciation or a depreciation? Depreciation. So is it going to be 1 plus or 1 minus? 1 minus. Very good. Okay, so you've got the table. Notice his land is decreasing over time. On the next page, define your variables, come up with the regression equation, and then we'll talk about it. So I'm going to pause here for a moment. Okay, so domain was what? And range was? Good. Menu, analyze, regression, exponential. There it is. Okay, please tell me the original amount of acres the farmer had. 1,250 acres. Original acreage, 1,250. Please tell me the rate of depreciation. Remember, it's 1 minus the rate. Think money, guys. If I have $1 and now I have 85 cents, how much have I depreciated? 0.15. So give that to me as a percentage, please. Okay, you have $1. You guys got $1, right? Now I have 85 cents. How much did I spend? 15 cents. Okay, now tell me what my percentage is. 15%. I don't either. Okay, so 15% depreciation each year. Okay, so do you understand how we find the value of depreciation, the rate of depreciation? So it's always, you're either going to subtract it from 1, right? We did 1 minus something was equal to 85. So how do we get it? How do we get it, guys? X. How do we get the value of x? Think like an equation. Killing me, killing me.
Add 85.
Negative x equals negative 15, which means x equals, okay, good. Huh? You'd have to divide by a negative 1. Okay. All right. Okay. All right, so we already have the equation right on the other page. All right, so let's talk about the equation. My general equation, again, is A equals P times 1 plus or minus R raised to the T. All right? That's my equation. We need to know what, put your book away. We need to know what each one means. What does A mean? In the book, where it's always been the amount afterwards. So the amount at the end, or current, depends, okay? So what you wind up with. P. What's that value that sits out front equal? The initial amount, or principal amount. Initial, original. Those are all good words. Okay? It's the original amount. What you start with. R, rate. And how does it have to be written? Good. T. Time. Generally how? What kind of time? Yeah, usually in years. Unless they specify months. Okay. 1 plus r. What does that usually do for us? What does it always do for us? Bigger or smaller? Bigger. So we call that word, yeah, starts with an A. It does, starts with an A. What is it? What's that word? Get bigger. What's it mean? A. Yeah. Appreciation. Another word, growth. Okay, growth. 1 minus? You remember that one. Depreciation. And another word for depreciation is decay. Growth and decay. And you'll see growth and decay used quite a bit. Probably more so than appreciation and depreciation. And growth and decay should be familiar from science, right? We use a lot of examples with growth and decay of bacteria. Those come up a lot. Anybody else dying, Pete? Okay, next page. So, general form of an exponential function can be written as y equals a times b raised to the x power. There's your general form for an exponential. You need to write this down. You need to write this down too. You are not exempt. You are not. Y equals a times b raised to the x, where b represents your base. Okay, there's your base. And that's going to be your growth or decay factor. Okay. When b is less than 1, b is a decay or a decreasing function. When b is greater than 1, it's a growth or an increasing function. Okay, so if your base is less than 1, meaning fractional, it's going to be a decay. If b is greater than 1, it's going to be a growth. It's going to get bigger. Okay? Oops, holding a pen. Okay, so what we're going to do now is we're going to graph using the paper. So I didn't give you rulers yet. What I'd like you to do is put a nice big XY axis on that. Hey, look at that, you got them. Nice big XY axis on your graph paper, please. Please don't break my rulers. I do buy them myself. Okay, so I've got the function y equals, okay, hold on. Okay, so what I want to do is I want to create a table. I don't want to plug this into the calculator. I want you to see what a table might look like, okay? So 24 times 1/2 raised to the x, we're going to make a table of values, and we're going to graph the coordinates and connect with a smooth curve. So we're going to, for the sake of time, pull up a table for this. So we're going to graph this. So Control-I, add a graph page. 24 times 1/2 raised to the x. Okay. Pull up a table, Control-T. All right, so what I want to do is I want to look at this function as x approaches negative infinity, which means going this way, and as x approaches positive infinity, which means going this way. Okay? So, as x approaches negative infinity, where's my function going? Up. Like up really high, really fast, right? So what about when x is approaching positive infinity? Down. Down to where? Not going to infinity. Where's it going? It's getting really small. It's getting closer and closer and closer and closer and closer to zero. Is it ever going to touch zero? No, it's not. Does anybody know what that's called? Why that occurs? What's there that's making it so it's not touching it? Asymptote. That's what it's called, okay? So what's happening here is this function is never touching the x-axis. What's the equation of the x-axis? Y equals 0, okay? The equation of the x-axis is y equals 0, okay? So what that means is this function never equals 0. There's no value that I can plug in for x that's going to make y equal to 0, ever, okay? So what we call that is it's a horizontal asymptote, and it's at y equals 0. Okay, so what I want you to do is I want you to pick some points, and I want you to graph this function on your paper, and we're going to write down some information about it. Okay? So 0 is 24, right? So go by 2s. Improvise, dear, improvise. One is what? 1 is 12? Don't say shut up. It's not a nice word. Okay, they're not nice words, plural. Is that better? Fix my grammar for you? No, just make sure you write your scale. So if you go by 2's on the y, put a little 2. If you go by 1's on the x, put a 1. Got to specify. Okay, what is 2? 6. Oh, so we went from 24 to 12 to 6 to 3. What's happening to each value? Decreasing by how much? Half. It's cutting it in half. Where does that half come into play? It's the, what is this called? It's the, starts with a B, the base, right? So the depreciation rate is 0.5. That means we're cutting it in half each time, right? It's getting to be half the size. So 4 should be 1.5, and then 5 should be 0.75, right? And then it gets smaller and smaller and smaller. It's really never going, I can't see through my shadow. It's really never going to touch that line, really, really. Not even at infinity. It's just going to get smaller and smaller and smaller. This is really hard to do on a smartboard. Smaller and smaller, okay, without ever touching it. Oh, that was a failure. Good job. Don't laugh at my failure. That's not a nice thing. Okay, so there's my function, right? So does it ever stop? No, it goes on and on forever in either direction, right? So my asymptote is what again? What's my asymptote? Yeah, never touches the x-axis. What's the x-axis? What's the equation? Okay, my asymptote is y equals 0. That's, the function is never going to equal 0, ever. Okay, there's no value of x that I can plug in to make this function equal to 0. Are we okay with that? I do not get nearly as far with you guys as I do my first period class. Strange boy, strange boy. Okay. So, y equals f of x, f of x equals b raised to the x is what we call the parent function. Parent function is before we mess with it, right? We're not multiplying it by anything. We're not adding or subtracting anything. What that value of a that sits up front does is it stretches it and it shrinks it, and it flips it upside down. okay, reflects over the x-axis. Okay, so that value of a is what changes my exponential function. And of course, the base makes it either increase faster or decrease faster or less fast. Okay, so I want you to go ahead and graph these two on a graph page. So just, and I think there's a graph page on the next page for you. Okay, you're going to graph those two functions and tell me what has happened. Oh, jeez. Here's my original. What happened, guys? One is decreasing, one is increasing. Why? Okay, but is one decreasing and one increasing? As time is going on, what's happening to my black function? It's increasing. As time is going on, what's happening to my purple function? It's decreasing, getting smaller. Okay. So what has happened to it? What's the difference between the black one and the purple one? Why? Where's the negative? Right. For the value of a, my value of a is negative. What do we call this when we're talking about a transformation? How was this transformed? Good, it was reflected over the x-axis. Perfect. Okay, so if you make that value of a negative, it reflects it over the x-axis. Are we okay with that? Yes? Okay. All right, so translating y equals a times b raised to the x, what we're going to do is we're going to pick up here next class. Okay, this lesson, again, is going to take us 2 days. So in your packet, you can only do 2 through 5. 6 and 7 are going to have to wait. So make that adjustment. This is a 2-day lesson. Okay? Don't forget, tests must be completed by the end of the day today. So get your butts in here to do that, please.